Does the universe have an edge? If you traveled far enough, would you reach a boundary? What lies beyond the observable universe? And what if there is no edge at all? To understand this question, we first need to understand something even stranger. Just how unimaginably large the universe really is. Let's begin with something familiar: the moon. The average distance between Earth and the moon is about 384,000 kilometers. That sounds enormous, but in cosmic terms, it is incredibly close. If you traveled to the moon using a commercial airplane flying at around 900 kilometers per hour, the journey would take roughly 18 days, and that is only our nearest celestial neighbor. Now let's move farther. The Sun is approximately 150 million kilometers away from Earth. Light from the Sun reaches us in about 8 minutes. But an airplane? At airplane speed, reaching the Sun would take over 19 years of non-stop flight. And remember, the Sun is just one star among hundreds of billions inside our galaxy. Mars is much farther away. Depending on planetary positions, Mars can be between 55 million and 400 million kilometers from Earth. Modern spacecraft require around 7 months to reach it. With an airplane, the trip would take decades. And Mars is still considered nearby in our solar system. Beyond Mars lie Jupiter, Saturn, Uranus, Neptune. Neptune, the farthest major planet, is about 4.5 billion kilometers from the Sun. Light from the Sun takes more than 4 hours to reach Neptune. And beyond Neptune lies something even larger: the outer boundary of the solar system. In 1977, NASA launched the spacecraft Voyager 1. Today, it is the most distant human-made object ever created. After nearly 50 years of travel, Voyager 1 has only just entered interstellar space. And yet, it has traveled only a tiny fraction of the distance across our galaxy. That is how enormous the Milky Way truly is. Our galaxy contains roughly 100 to 400 billion stars, vast clouds of gas and dust, possibly trillions of planets. The Milky Way itself is about 100,000 light-years wide. That means light, traveling at 300,000 kilometers per second, requires 100,000 years to cross it. If an airplane tried to cross the galaxy, it would take over 120 billion years, longer than the age of the universe itself. The closest star to Earth after the Sun is Proxima Centauri. Its distance? About 4.24 light-years away. That means even light requires more than 4 years to reach us. An airplane would need millions of years. This is where the scale of the universe starts becoming difficult for the human mind to process. Now, let's go even farther. The nearest major galaxy to us is the Andromeda Galaxy. It is about 2.5 million light-years away. The light entering your eyes from Andromeda tonight began its journey before modern humans even existed. And yet, Andromeda is considered our cosmic neighbor. This leads to one of the strangest facts in astronomy. When we look into space, we look backward in time. The farther away an object is, the older the light we see. Some galaxies observed by the James Webb Space Telescope appear as they were over 13 billion years ago. We are literally seeing ancient history written in light. Everything we can see exists inside what is called the observable universe. Its radius is approximately 46 billion light-years. Not because the universe ends there, but because the universe has existed for a limited amount of time, and light beyond that distance has not reached us yet. This creates a cosmic horizon, a limit to observation, not necessarily a limit to existence. At the edge of our observable universe, we detect the cosmic microwave background. This ancient radiation formed about 380,000 years after the Big Bang. It is essentially the oldest light we can ever observe. Beyond this point, the early universe was opaque. Light could not travel freely yet, so our cosmic map fades into darkness. Many people imagine the universe like a giant box, but physics does not support this idea. There is no evidence of a wall, a border, or an ending point in space. Instead, space itself expands, and it expands everywhere simultaneously. Imagine tiny dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. No dot is the center. The surface has no edge. This is similar to how our universe behaves. A universe can be finite without having an edge. Beyond the observable universe, there is likely more universe, more galaxies, more stars, more cosmic structures, possibly infinitely more. We simply cannot see those regions, not because they do not exist, but because their light has not reached us, and some never will, because the expansion of space is accelerating. Scientists still do not know whether the universe is infinite, finite but unbounded, or part of something larger. Current evidence suggests space is remarkably flat, and a flat universe may continue forever. If true, the universe may have no edge at all. This question may not even make physical sense. If the universe contains all space and time, then there may be no outside. Asking what exists outside the universe could be like asking, what is north of the North Pole? The question itself may be flawed. Some cosmological theories suggest our universe may be only one among many, a multiverse. In this idea, different universes may have different laws of physics. Space may contain endless cosmic bubbles. Our universe may be just one region in something vastly larger. This remains theoretical, but it shows how little we still know about ultimate reality. So, does the universe have an edge? Probably not in the way we imagine. There is no known wall waiting at the end of space, only horizons, limits created by light, time, and expansion. And beyond those horizons may lie more universe than we can ever comprehend. The deeper we explore the cosmic map, the more we realize that humanity exists on a tiny island of knowledge inside something unimaginably vast. And perhaps the most mysterious part is this: no matter how far we look, the universe may never truly end.